So now we're going to talk about the audio system. So the main hub of the audio system that the user will interact with is this idea of the audio emitter. This is an object that they can build. It's a scene component, just like the update component, a particle emitter, a collision component. These are all just things that exist in the scene. And it has a whole host of fun functions for play, pause, stop. You'll start this, the 3D updating and then 3D positional data objects or functions. These are not fully used yet. The front end is complete, but the actual back end where I'm using that data and passing it to Xaudio 2, I did not finish. I just do not. It got too close to time and I didn't want to mess with Xaudio 2 because the documentation makes it sound simple, but they often leave a lot of stuff out. So I ran out of time on that one. And now you'll also notice that this guy's in here. The pooled resource iterator, the old friend. This is a common pattern that you'll see throughout our whole engine, and one of the biggest reasons, again, why I want to write my own memory system. Because this guy is great, but it really has introduced templates all throughout our engine. So there are certain data bits of information that the audio emitter is allowed to control, but the most of it actually goes in this audio emitter data object. Most of these are just so when the user says like get pitch, it just returns it. So if I set pitch, you just set your pitch to that and then you return it. This is a nice way of making it so I don't have to do any locks for the user to actually interact with this. So when they say set pitch, they're actually submitting a command to have that applied to the audio emitter data, and then they keep this little float scuttled away just so they can do a nice getter. So you'll see that up here, like the volume, volume, pitch, and pan. They all do that way. So we'll go into the audio system. You'll see him up here a lot in here. But for now, we want to talk about this iterator data, because this is by far the juiciest bit of the entire engine. And you'll see a lot of these functions are often just saying hey, like audio system, do something to iterator data. That's what most of these functions are actually doing. So, what is it? So, for starters, you can already see that it's overriding the Xaudio 2 voice callback. So, the Xaudio 2 system works with, they refer to them as mastering voices and source voices. The mastering voice is the one large one that basically represents the whole sound of the engine. A source voice are little streams of information that flow into the mastering voice, more or less, for lack of a better analogy. So, as you can see right here, this is hooking into a voice, a source voice to be exact. And you'll see it right here. It's overriding a ton of these functions. So anytime that I need to communicate with Xaudio 2, this is how it communicates with me. It calls one of these functions. And then you'll see these guys appearing again. So again, the audio emitter object itself that the user has doesn't actually do anything. When it comes to playing, pause, stopping, it's sending requests to apply it to this object. So when you say set volume, you're actually sending a command that will then do source voice set volume. So, let's introduce two new ideas. There's the audio clip and the audio file. So an audio clip is something that's already been loaded into the engine using the audio clip manager. I briefly mentioned this in the task system because he has the load async, which is just a fun little function that I'm very proud of. Just because I like how well it worked. So, audio clips are preloaded, but if you pass an audio file, that means you are asking to stream that information. So if you want like a really long song, you don't want to load the entire song into the engine. What you should instead do is give the name of the song, and instead have the audio emitter stream that data in at runtime. That way you're holding far fewer bytes in your engine than you need. So, back to the data. So when you initialize it with an audio clip, as you can see right there, all it does is ignore all the source voice stuff. There's a lot of X-Audio2 is a big. It's doing a lot for me. So when you pass the audio clip, you do source voice, submit to source buffer. So there's the idea of the buffer. So the buffer is what actually makes up all the sound information. You have the chunk size and the actual data buffer. Yikes, I need to come up with better naming schemas because data buffer is a very common thing named throughout the engine. So an audio clip is just this X-Audio2 buffer. That's largely all it is. It's just a handy wrapper for all my work around him. So when you load an audio clip, you're basically saying, put it into my buffer, and then send that into that source voice. So when you submit a buffer into a source voice, now when you play, it's going to start reading from that buffer. And you'll notice that is juxtaposed against when you instead initialize it with an audio file name. That will actually work with this guy. Yes, he has the P. He's not technically a pointer. So, audio emitter buffer streamed is a special object I made that does all the data streaming. This guy is where I went a little rogue. I didn't like the X-Audio2's documentation on streaming doesn't actually work if you copy and paste the code. There's a lot missing from what they did, so I went off and did my own. It works very well, or fairly well. Obviously, there's always room for improvement, but the basic idea is that he's actually using this task, stream audio clip, and this audio clip task will call his own function called stream data. Stream data. So that task lives on the object, the audio emitter data. Or sorry, the streamed audio emitter data. It's a separate class. And then he's just calling stream data on it. So this allows you to have a separate thread stream in there. And just here's my handy little thing where the task is not complete until you finish this loop. And so you just lock it, load a chunk, unlock it, try it again, and you just keep going until you're done. That's the basic gist of that. You can wake him with this little function. That's, the execute async is the magic secret sauce. Again, the task system is really just a bunch of commands that you'll see sprinkled throughout the engine now. I absolutely adore those guys. So the streaming, I don't want to go too deep into it. It's a lot of X-Audio2 specific stuff, but basically what it's doing is creating 3 buffers of data, and then it's always trying to keep those 3 filled. So it's always wanting to, the streaming task is always trying to keep ahead of the task, ahead of the buffers that are being fed into the engine. So when you actually submit him, submit buffer, right here. It's right here. Yep. So you're always trying to make sure that you always have one buffer ahead of the buffer that's being fed into the source voice. Because the source voice is also reading in here. Yeah, sorry, I'm a little hesitant about how deep to go into all this because there's a lot in here. But basically, audio emitter buffer streamed is just an object that literally all it does is stream audio buffer into these byte buffers and then submits those byte buffers into the source voice. That is the highest level of what it does. So again, audio emitter owns a pooled resource iterator that points to audio emitter data, who owns the audio emitter buffer streamed. So right now he always lives on there. Ideally I'd want to allow you to create or destroy him based on what your specifics were, and that's where I was trying to go. But I found that got real complex real fast. So I just made it live on the audio emitter data itself, which is, again, memory intensive, but it works fine for now. So, the audio emitter is basically sending commands to have the audio system apply these functions onto the audio emitter data. And that's how it will either submit those audio clips into the source voice, or it will stream small byte buffers into the source voice. So, where's the secret sauce about how are these commands being applied to these objects? That gets into the audio system. This is the actual singleton that owns the vast majority of this. For starters, he has two helper level functions about setting and getting the master volume. Not too interesting there. But what you'll see is he's a giant command queue. Vast majority of what he does is just holds commands and submits commands. And if you actually open all these up, they're all fairly straightforward. The pause audio command will call pause on the current audio emitter data, then recycle himself. That's all he does. Play, stop, very recurring ideas. So set pan, you just call set pan on that specific audio emitter data, and recycle. So the idea is the audio emitter will submit commands to the audio system to apply specific alterations to an audio emitter data. And that audio emitter data is what's actually communicating with XAudio2. Oh, and there's one, I mentioned briefly that the source mastering voice, there's one mastering voice and a bunch of source voices. One source voice per audio, one source voice per audio emitter. And there he is. The mastering voice actually lives on the audio system. So all the actual streaming about the exact specifics of the final sound that comes out of the engine runs through the audio system. The source voices are basically applying little like trickle streams into the mastering voice, more or less. So, audio emitter owns data, and he interacts with that data using the audio system. And that specific data that everyone's touching is the audio emitter data. And this is just the central hub. That's why he has so many mutex, or not. He has a single mutex, but you'll see him being locked and unlocked a lot all over the place. Ideally, this needs to go. If I was better with lock-free data structures, this would be a major, major hotspot where this needs to be as lock-free as possible. But without getting too deep into XAudio2, that's the largest high level I can give you.